This is Algebra 2, Lesson 2.2, Linear Relations and Functions. When you hear the word linear, you should be taken back to Algebra 1 and remember what linear is. Linear means it's a straight line. So if you hear something's linear, you should automatically think straight line. That's from Algebra 1. If you hear something's non-linear, obviously you'll think it's not a straight line. So linear, straight line, non-linear, not a straight line. So we're going to talk about some qualifications to be a linear equation. The first thing is that you can add, subtract, multiply variables with a constant. Constant being a number. So you can add, subtract, multiply, divide a variable with a constant. To be a linear equation, variables, some of you may remember this list from Algebra 1, cannot be multiplied together. So write these down in your notes as I'm writing them down. The third thing is variables cannot be on the denominator. The fourth thing, the variables must have an exponent that equals 1. And then the last thing that's pretty self-explanatory based on the definition above, that the graph of a linear equation is always a line. So let's do some classification of some equations here. So I'm going to give you some equations. We're going to classify them as linear or nonlinear. The first one, 4x minus 5y equals 16. This is linear because it does have variables in it. It has variables and constants multiplied together. The second one where it says variables cannot be multiplied together, x and y are not being multiplied together. Variables cannot be on the denominator. We have no variables on the denominator. The variable's exponents must be 1. The exponents on x and y are both 1. And if we would graph this, which you guys should be able to easily graph, remember put in slope-intercept form and put your first point on your slope-intercept and then up and over depending on your slope. But if you graph this or graphed it in the graphing calculator, it would definitely be a straight line. The next one, 2x plus 6y squared equals negative 25. This one is nonlinear. And the reason it's nonlinear is because of this squared that we have there. The next one, let's do y is equal to negative 2/3 x minus 1. This is linear, and it's in slope-intercept form. Let's do y equals the square root of x plus 2. This is nonlinear. And pause the video each time I write an equation down, and you decide if it's linear or nonlinear, and then push play and see if you were right. And it's nonlinear because of the square root here. Remember back to Algebra 1, the square root's really the same thing as x to the 1/2 power. And so this would not be an exponent of 1. So anything with a square root, cube root, fourth root, it's going to be nonlinear. We have x equals xy plus 5. This is nonlinear. I hope you got that one right. It's nonlinear because the x and y are multiplied together. Let's do y equals 1/2 x. This is linear. And the last one, y equals 1 over x. This is nonlinear. And it's nonlinear because of the x on the denominator. So these are all linear equations. All of those follow into the linear equations. Now let's talk about linear functions. And if you want to, you can get the definition from the back of your algebra book. So a linear function is a function with ordered pairs that satisfies a linear equation. Any linear function can be written in the form, so any linear function can be written in the form of f of x equals mx plus b. And you should remember this formula. The only thing difference, it's in function notation, and it's got the f of x instead of y. So y equals mx plus b, your slope-intercept form. So we're going to state whether the following functions are linear functions. And the same rules apply, that's not a function. The same rules apply to the linear functions as the linear equations. If you cannot write it in slope-intercept form, most likely it's not a linear function. So this first one, we could write this in slope-intercept form because we could write f of x is equal to negative 3/4 x plus 8. 3/4 is my m, 8 is my b, so yes, this would be a linear function. The next one, f of x equals 2 over x. This is a no before we even try to put it in slope-intercept form because of the x on the denominator. F of x equals 3xy minus 4. Again, no before we even try because they're multiplying x and y together. Up here, y, which remember is f of x, and x are never multiplied together. The next one, f of x is equal to 5 over x plus 6. Again, this is definitely a no because of the x here. The last one is f of x equals negative 3/2 x plus 1/3. And this is definitely a yes, and it's already in slope-intercept form. This is your m, this is your b. So that's slope-intercept form. Let's talk about standard form. Last year in Algebra 1, we used standard form a lot more than any of the other previous years that I've done this. And remember, standard form is ax plus by equals c, where a, b, and c are equal to real numbers or integers, equal to integers, which are real numbers, with a greatest common factor of 1. A has to be greater than or equal to 0. A and b are not both 0. Okay. So a can be equal to 0. It can't be less than 0, so it can't be negative is really what they're saying there. So let's do an example of putting them in standard form and then identify a, b, and c. So 2y is equal to 4x plus 5. We want to put this in standard form and then say what a, b, and c are. So if you notice, x and y are on the same side. So what I really want to do is I want to take this 4x and I want to take it over there with that 2y. So to move it over, I would subtract it. That cancels. And so I have negative 4x plus 2y equals 5, which is in standard form except for one thing. Right here where it says a is greater than or equal to 0, our a is negative, so it's not greater than or equal to 0. So to fix that, we'll just distribute a negative 1 to the whole problem. If I did it to one side, I can do it to the other side. So that's how I can get away with multiplying one side by negative 1. As long as I do it to the other side, it still keeps my equation balanced. So that would become 4x minus 2y equals negative 5. Now this is in standard form. My a is 4, my b is negative 2, and my c is negative 5. So it's in standard form, and we can pick out a, b, and c. The next one, 3x minus 6y minus 9 equals 0. And I'll write standard form over here so we can see it as we work this problem. So again, we need the x and the y on the same side, and we need to move the 9 over because we want that c over there by itself. So to move that 9 over, I'm going to add 9 to both sides, so 0 plus 9 is 9. And so it looks really good in standard form, but I'm going to show you something really cool. If you notice, all of these are divisible by 3. Standard form wants you to put it in the simplest form you can do. So if I divide all that by 3, I've reduced my problem to be lower numbers. So now my a is 1, my b is negative 2, and my c is 3. On any type of standard testing, your ACT, your EOC, they will always reduce those. So you could have this answer and be correct, but not have it in simplest form. So you need to make sure you can simplify that down anytime. Let's do one more. I'll change colors here. So negative 3/10x is equal to 8y minus 15. So we got the x over there. We just need this y, this b and this y, over to the other side. So we have negative 3/10x, and so we're going to, if we move the 8y over, we'll subtract 8y equals negative 15. So if you remember back to our rules, a and b, let's get that out of the way. A and b are not both 0, and a has to be greater than 0. So right here we can't have this negative sign, and you can't have any fractions either. So the way we're going to get rid of that is we're going to multiply this whole thing by negative 10. So right here the negative and the 10 will cancel. You'll end up with 3x. A negative times a negative, we have a positive. 10 times 8 is going to be 80. And negative 10 times negative 15 will be 150. So remember, anytime you have a number on the denominator, you're going to multiply by that number and it'll get rid of that. So our a in this case is 3, our b is 80, and our c is 150.